Hello, here we're going to take a look at the quotient rule of base to the power of m divided by base to the power of n, and the result is equal to base to the power of m minus n. So in our first example we have x to the 5 divided by x to the second. This power of 5 means we have 5 factors of x, so 1, 2, 3, 4, 5. Out of x to the second means we have 2 factors of x in denominator. We can reduce this because x divided by x cancels into 1. Second x divided by second x cancels into 1. And we get 3 factors of x in numerator out of 1 in denominator, and this simplifies into x to the third. We can get the same solution by taking original base from the problem, which is x, and having the numerator power of 5 minus denominator power of 2. And this will give us x to the 5 minus 2, which is 3 as well. So x to the third is our solution. In this example, we have to simplify x to the third out of x to the fifth. And using the quotient rule, this is equal to x, numerator power of 3, minus denominator power of 5. And this will give us x to the 3 minus 5 is equal to negative 2. So x to the negative 2 is our solution. I would like to point out that if we rewrite this fraction as x to the third is x times x times x, out of x to the 5 is 5 factors of x in denominator. After we reduce 3 factors of x in numerator and denominator, we are left with all the x's cancel out in numerator, so we have 1 out of x times x in denominator, and this gives us 1 out of x to the second. This is also a perfectly fine solution because this is a definition of negative exponents. In this example, we have to simplify x to the second times x to the fourth out of x times x to the third. So before we use the quotient rule, this 1x in denominator has power of 1. That's the identity exponent. So now let's use the quotient rule. We have the base is x. The order in which you write down the exponents does not matter. What matters is that you remember that whatever comes from numerator has positive sign. So x to the second was in numerator, so the power of 2 is positive. X to the first was in denominator, so 1 will be negative, so 2 minus 1. X to the fourth was in numerator, so we have plus 4. X to the 3 was in denominator, so minus 3. So let's combine these from left to right. We have x to the 2 minus 1, we have 1, plus 4 minus 3. This will give us x to the 1 plus 4 is 5 minus 3. And this will give us x to the 5 minus 3 is 2. So x to the second is our solution. In this example, we have x to the third divided by x to the third. If we apply the quotient rule, the base is x. The exponent in numerator was 3 minus the exponent in denominator was also 3. So 3 minus 3 is the exponent. This will give us x to the power of 3 minus 3, which is equal to 0. Let's take a look at what exponent of 0 really means. We have x to the third in numerator, so this means we have 3 factors of x in numerator. Out of, we have x to the third in denominator, so we have 3 factors of x in denominator. And x out of x cancels into 1, x out of x cancels into 1, and x out of x cancels into 1. So we have something divided by itself equals to 1. So any base to the 0 exponent is equal to 1. That's all.